Welcome back. We're on lesson number 2 of trigonometry. We're going to talk about special right triangles in trig in this lesson. So we should have remembered from earlier lessons, maybe in geometry, about sine, cosine, and tangent, the first 3 trig functions, right? These ones right here. And we remember each of their ratios thanks to SOHCAHTOA, right? Ring a bell? Okay, so we know sine is going to be opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And if you know me at all, you know that I will freak out if I hear you call this sin or cos. Tan's okay though, you can abbreviate that to tan. Okay, so those are the first 3 that we've talked about. Now we have 3 more that we're going to start talking about, which are secant, cosecant, and tangent. And we're going to abbreviate secant to SEC, cosecant to CSC, and cotangent to COT. Okay, and just like sine, we don't want to call it sin. We're not going to call this sec. Okay, this is secant. So, how are we going to remember which ratios and how they work? Well, secant is going to be hypotenuse over adjacent. Cosecant is hypotenuse over opposite. Cotangent is adjacent over opposite. And how I've always remembered these ratios for these last 3 is I write them exactly in this order. The first 3 that I know, the second 3 that I know, and then I just do this to fill in my ratios here. I know, by the way, these are inverses. Okay, I know that cosine and secant are going to be reciprocals. Okay, so I know cosine is a over h, secant would have to be h over a. Sine is o over h, so that means cosecant is h over o. And last, OA for tangent, so cotangent's a over o. Okay, so I use that little trick, the way I set it up, and just drawing the little cross and line. Maybe that doesn't work for you, I don't know, but we need to make sure that we get these few ratios for these new ones down pat, because we're going to be using them for the rest of trig, which is 3 full units, including this one. Okay. Next, let's see how these things work. Okay. So here we have a triangle. It's a right triangle. All of them are, in fact. And we want to find secant of theta. So just like we've done in the past, we're going to put theta wherever it is, and then we're going to mark the sides that we need. I know secant is A and H, so my adjacent side, which is right next to it, and my hypotenuse, which is always across from 90, and all I have to do is just put them in the correct order. So secant of theta is going to be 85 over 13. For cosecant, from theta, cosecant is h and o. So I label my hypotenuse, right? I label my opposite, and I just got to make sure that I put them in the correct order. I want hypotenuse on top and opposite on bottom. If I can reduce, which this does, they're both divisible by 2, I'm going to. Right? 50 divided by 2 and 14 divided by 2. That leaves us with 25 over 7. So there's one more for you to try out, which is cotangent. Pause this video and resume it when you're ready to check your work. Alright, how'd you do with this? We want cotangent, which is going to be adjacent and opposite. So from here, my adjacent side, which is right next to it, and my opposite side. But we want A over O. So we want 11 over 60. Not bad, right? Now let's talk about special right triangles. These are kind of cool little puzzle problems, I think. They're very useful in trigonometry. We're going to be using them quite a bit to help us build a unit circle in the next lesson. Okay, but for right now, they're pretty cool to work with, right? We've got two types of special right triangles. We have a 45, 45, 90, which you can see includes two 45-degree angles plus the 90, and we have a 30, 60, 90, which includes a 30, a 60, and a 90-degree angle. Now, because these angles are equal to each other, that means we have an isosceles triangle, which means that both of these sides are going to be the same. Do we know what they are? No. But we do know if we were to use Pythagorean theorem the right way, we would find that the length of this side is equal to x times the square root of 2. So what's really cool is that if I have any number here, like let's say 5, I know that this x is going to become 5 and this side is going to become 5 root 2. Right? Pretty easy to work with. 30, 60, 90, a little bit trickier to remember. So there's a trick that's the 1, 2, 3. Okay, our 1 is going to be the smallest. 2 actually becomes the biggest because it's going to be 2 times the number. And then 3 is our middle sized because it's under the radical. So although it's not the easiest to remember where each of them go, it is easy to remember that I have 1 unit here, I have twice the unit, and then a 3 appears. So what I would suggest is practice these a couple of times and get used to where those numbers belong. Right, 45, 45, 90 is really easy because these two are the same, and then you got x root 2. This one, people sometimes switch them around. Okay, we want to make sure across from the 30 is our smallest, across from the 60 is our second smallest, across from the 90 is our largest. Okay, and the 1, 2, 3 sometimes helps. Anyways, enough repeating myself. Let's look at some problems. Okay, and if you don't have these written yet, I would suggest drawing these out real quick because we're going to be using them for the next couple of problems. Okay, so here's what we do. We identify which one of these two that we have, and then we start filling in these on the triangle themselves, right? So we have a 45, 45, 90. So I know that these two sides are going to be my x's, and this is going to be my x root 2. I already know what x is equal to. It's whatever this side is. So here, if x is 2 root 3, that means here x has to be 2 root 3, which is what my a that I'm trying to find is. So a is going to be 2 root 3. Right? Because they're the same. B, I have a little bit more work, right? B says I need to take x, which is 2 root 3, and I need to multiply by root 2. Okay, it's not difficult work, it's just multiplication. The stuff on the inside of the radicals we can multiply with no problem. Stuff on the outside we're going to just leave alone. So we've got 2 on the outside and root 6. So B's value is 2 root 6. If you know me at all, you know that I don't care for decimals all that much. I'd much prefer you to leave it in radical form. So these are completely accurate answers. If you were to give me a decimal and round, you'd be cutting it off somewhere, which is not as accurate as what we see here. So those are cool. Let's leave them alone how they are. Okay, we're going to see a couple more problems of those. We're going to look at the 30, 60, 90 one next. Okay. But the process is going to be the same, right? I'm going to figure out the type of triangle and then start filling in the blanks that I need, right? I know this would have to be my 30, and across from my 30 is my x. Across from my 90 is my 2x, and then my x root 3. Okay, so I've taken the time to just put those little labels in. They told me that the side where 2x is worth 10. So if I divide by 2, we find x to be plain old 5. I needed that for both of these, right? B is just x's value, so B is going to be 5. A is going to be x, which we found 5, times root 3. So A is going to be 5 root 3. If that simplified any further, I would, but that's as simple as that gets. Those are the solutions for that problem. Okay, so I have two right here for you to try out. Again, identify which type of triangle they are first, fill in those labels, and then solve. So I want you to pause this video and resume when you're ready to check your solutions. All right. Our first one, 45, 45, 90, we know both sides across from the 45 are going to be equal to each other, and then we have x root 2 for our hypotenuse. They gave us 3 root 5 for x. That means b, which is the same as x, is going to be 3 root 5. That one wasn't too bad. As far as a, we have x's value, 3 root 5, times 2, or root 2. So here we go. A is going to be 3 root 5 times root 2. Again, only the things on the inside of the radicals can multiply together, so we get 3 root 10. Those are your A's and B's. Your other problem that you were to try, you should have identified this as 30, 60, 90 because of that little 30 right here. We know across from 30 is going to be plain old x. Across from the 90 is 2x, and then x root 3. Now again, they gave us our x value right away, right? 7 root 2 is what x is equal to. So when I'm looking for a, I'm going to plug in this x value, 7 root 2, times root 3. Okay, so let's see. 7 doesn't go anywhere. 2 times 3 is 6, so a is equal to 7 root 6. B, they have 2 times x. So for b, we have 2 times 7 root 2. Now, only the things on the outside can multiply. The root 2 is going to stay how it is. So we come up with b equaling 14 root 2. Okay, special right triangles, not really that bad, right? If you fill in what pieces go on each side, they're really not that bad. Okay, so here we go. Now we're going to work with the trig functions that we talked about before and the special right triangles. Okay, so our process is going to be a combination of how we would solve a trig function, which is labeling theta, identifying which sides for the function we're using, and we're going to combine the 30, 60, 90 triangles to figure out what each side's worth. Okay, so it's a little bit of 2 lessons in one now. Okay, here we have theta at 60 because they want cotangent of 60, so we put theta in place. Cotangent, if we remember, is going to be equal to a over o. So I need my adjacent side and my opposite side. This is my adjacent side, and this is my opposite side. Now, this angle we know is 30 because it's a 30, 60, 90. So across from my 30 is going to be my x value, and across from my 60 is going to be my x root 3 value. So all I have to do is plug in really each of these. X root 3, that stays the same, so I have root 3 times root 3, which is just plain old 3. So for cotangent at 60, I'm going to have my adjacent, which is root 3, over my opposite, which is plain old 3. Okay, let's look at another one. Okay, we want to find cosecant of 45. I'm going to make a little note right here. Cosecant is going to be equal to hypotenuse over opposite. Here's my 45. That means that this is also 45. And we know that both of these are going to be x's. And we know that this is going to be x root 2. Now I'm going to put theta at the angle, and I'm going to use the one that they gave me. It doesn't really matter all that much, but I tend to work with things that they give me. That way, in case I made a mistake labeling, I don't have to worry about it. I'm using what they gave me. Okay, so I have my theta at 45. We know that we need the hypotenuse, which is right here, and we need the opposite, which is over here. Now, x is worth root 2. So we have root 2 here. Hypotenuse is going to be x, which is root 2, times root 2. Alright, so we got root 2 times root 2, which is really just plain old 2. And now we have enough to write down cosecant, right? We needed hypotenuse and opposite. So cosecant of 45 equals 2 over root 2. But there's a slight problem. We need to rationalize, right? We can't have a radical on bottom. How we get rid of that is multiplying by that particular value, right? Root 2 over root 2. That's going to give us root 2 squared, which is 2. And then 2 root 2 on top. And we still have a little bit of problem here because we want to reduce as much as we can. And those 2's are going to eliminate. So here it is. Cosecant of 45 is going to equal root 2. Okay, there's 2 more problems, just like the ones that we tried just now, for you to try out on your own. So try these 2, pause the video, and resume when you're ready to check your solutions. Alright, let's check them out. We're working with a 45, 45, 90. So this is going to be an x, this is going to be an x, this is going to be x root 2. We're working with secant, which we should know secant is h over a. So I need my hypotenuse and I need my adjacent. I don't really even need this. So x is worth root 5. So we're going to end up having root 5 times root 2, which is root 10 for our hypotenuse. We already know our adjacent side is root 5. So secant of 45 equals root 10 over root 5. Still got to rationalize, can't have root 5 on bottom, so we're going to do root 5 over root 5. That's going to give us 10 times 5 is 50. Root 5 times root 5 is just plain old 5. That 50 now we can start breaking down. I know that it's like, okay, we've got to an answer, but we can keep on simplifying, right? We don't want to leave it like this. So that 50 is going to break up into 25 times 2. It's still over 5. Why did I choose 25? Because it's a perfect square and we're taking roots, right? So if I take the root of 25, we get 5 to come out. 2's not able to come out yet. So we got root 5 over 5. Those 5's are going to cancel. So secant of 45 degrees is going to equal the square root of 2. Again, don't give me decimals. I don't want them. Give me full answers. Root 2 is perfect. Okay, you had one other to try on your own, and it was cosecant of 30. So across from our 30 is our x value. That would mean that this is 60, and across from 60 would be x root 3. And then across from our hypotenuse is 2x. Cosecant is going to be h over o. So here we go. Here's our x value. It's 3. So if we do 2 times 3, we get 6. And that was our hypotenuse. Our opposite from 30 is just this 3. So we don't even need this side. I'm going to get rid of it. Okay? Right? H and O. So cosecant of 30 equals hypotenuse, which is 6, over opposite, which is 3. That clearly reduces to 2. So cosecant of 30 degrees is 2. That's it for special right triangles and trig. They're really not that bad once you get used to the special right triangles themselves. The trig functions take a little bit of practice, but again, it's only a couple of things to memorize. So if you have any questions, leave them in the comments, or even better would be to bring them into class and I can speak directly with you. And I guess that's it. So see you next time.